A sail is essentially a vertical wing that provides forward thrust and lift to propel a boat over water. It's impossible to know who came up with the concept because boats with sails have been plying waterways for thousands of years. But when it comes to their design and construction, today's sails have come a long way. For thousands of years, sails were square. But in the 3rd century, triangular sails appeared on the Mediterranean. The shape enabled boats to sail into the wind as well as with it. Modern racing sails are made of laminated synthetics. They start with a plastic membrane. Rollers apply a hot liquid adhesive to one side in measured amounts because even a couple of extra grams would weigh down the sail. They press a scrim onto the hot adhesive. It's a super-strength synthetic called aramid, which will keep the sail from tearing. Then it's over to a computerized laser that cuts patterns out of the scrim-reinforced plastic. A worker rolls up each panel to transport it to the next work table. Here, they tape 10 to 20 of the panels together using heavy-duty PET plastic with an acrylic adhesive. Now hundreds of small jacks stretched aluminized plastic around a framework, pulling material into a curved aerodynamic shape. This mold will be used to shape the sail. The team stretches clear plastic film over it. Then they drape the joined panels over top. They use ropes and clamps to pull it to the contours of the mold. And now, they're ready for some super tough synthetics, aramid and carbon fiber yarns. The yarns have been coated with adhesive so they'll stick to the plastic film. A robot rolls the yarns onto the film while a worker follows in a harness overhead to keep an eye on the job. The robot applies the yarns in a pattern plotted by an engineer to anticipate the wind load on this sail. The robot now switches from a vertical path to a horizontal one, applying yarns in a transverse pattern. The team installs a long, narrow pocket over that section. A batten will later be inserted in this pocket to control the sail's shape. They pull another layer of scrim-enhanced plastic on top, and now all the layers of the sailcloth are in place. A worker hovers overhead to inspect the surface for defects. They now seal the assembled sail in a vacuum bag and attach hoses. The hoses suck out the air, pressing the layers of the sail together. Now the robot applies heat to the sail. It activates the adhesives in the plastics to laminate the layers together, and it also sets the three-dimensional shape of the sail. A worker inspects the job with a magnifying glass. Then it's over to a revolving sewing turret. As the sewing machine turns, it pulls the sail forward, allowing the operator to stitch hems, grommets, and reinforcements onto it. They apply the corporate logo. Next, a worker walks the length of this enormous sail to inspect it. No imperfections will be tolerated. After all, this is a big-ticket item. Large racing sails can retail for hundreds of thousands of dollars. Sophisticated engineering and high-tech materials have produced a racing sail that's lightweight yet incredibly strong. There may be rough water ahead, but with technology on their side, this crew should be able to sail right through it.